Okay, in this video we're going to be looking at variables, and we're going to define what a variable is. A variable may stand for a missing element for an unknown, as in this equation x plus 2 is equal to 5. In this case, the x is going to be the unknown. That means what value of x plus 2 will give you 5. Okay, now we're not only limited to just the x. We can use any letter of the alphabet from A to Z to represent an unknown or a missing element. A variable can represent more than one thing. For example, in a group of children, you could say that their heights vary with their ages. If H represents height and A represents age, then both H and A can have different values for different children in the group. Okay, so H can be representing any value of the child's height, and A can represent any value of the child's age. Variables can be used in generalizations of patterns. If we were to use actual values instead of variables, the instructions would only apply to a limited set of situations. A variable can also be an element of a set or a set itself. Like, for example, in the definition of the intersection of two sets, where you have A intersection B, that's represented by the set of all x, such that x is an element of A and x is an element of B. Here the x is a variable that represents any element that belongs to both sets A and B. So this is an illustration of how a variable can be used as an element of a set or a set itself. Now let's look at some examples of how we can translate word phrases into an algebraic expression. Like for the first one, part A says 2 more than a number. Well, the phrase more than means addition. So 2 more than a number would be n plus 2. We use n as the variable, which is the unknown, plus 2. Part B, the square root of 2 greater than a number. The phrase greater than also means addition, so we have a number, which is n, plus the square root of 2, which represents 2 greater than a number. Or you can say the square root of 2 plus n, just like we can say 2 plus n as opposed to n plus 2. Either way, you'll get it, they represent the same phrase. 2/3 less than a number. Now we cannot say 2/3 minus n. We must say n minus 2/3. This is a common mistake that most students make when they translate something like this into a algebraic expression. Think of a number, which is going to be n. 2/3 less than that would be minus 2/3. So it'll be n minus 2/3 and not 2/3 minus n. Part D, 2 times a number will be 2n. Now notice the n is next to the 2. That represents 2 times n. Sometimes they write the dot between the two numbers or the two expressions means 2 times n. But normally we write that as just 2n. We know that's going to be a multiplication. And part E, a number times itself will be n times n. Or we can say n to the second. Okay, because n is used as a factor 2 times, so we can write that as n to the second. So this is how we can translate some of these word phrases into algebraic expressions. And there are more, like this one. The cost of renting a car for any number of days if the charge per day is $40. If we let n be the number of days that we rent a car, then the charge will be 40 times n, or the cost of renting a car would be 40 times n, because we're charged $40 per day, so 40 times n would represent the cost of renting that car. And then G, the distance a car traveled at a constant speed of 65 miles per hour for any number of hours, that's going to be 65 times h. We're letting h be the number of hours. At 65 miles an hour, that'll be 65 times h. miles. One weekend, a store sold twice as many CDs as full-size DVDs and 25 fewer mini DVDs than CDs. If the store sold D full-size DVDs, how many mini DVDs and CDs did it sell? Okay, now to translate this, because we're going to let D be the full-size DVDs were sold. In this case, twice as many CDs as full-size DVDs would mean, as an algebraic expression, 2 times D. So it'll be 2 times D CDs. Now, there were 25 fewer mini DVDs than CDs. That would mean 2D, which is the number of CDs, minus 25. That represents the number of mini DVDs. Okay, so here we can take this sentence, this statement, and try to translate this into an algebraic expression. Let D be the number of full-size DVDs. 2 times D represents the number of CDs because we're told that the store sold twice as many CDs as full-size DVDs. And then there were 25 fewer mini DVDs sold than CDs. Well, 2D represents the number of CDs sold. So for the number of mini DVDs sold, it'll be 2D minus 25. All right, next, French fries has about 12 calories apiece. A hamburger has about 600 calories. Akiva is on a diet of 2,000 calories per day. If he ate 5F French fries, ate F French fries and 1 hamburger, how many more calories can he consume that day? All right, in this case here, we want to find out how many calories Akiva consumed eating F French fries and 1 hamburger. And then we're going to find out how many calories he can consume by subtracting this expression from the 2,000. Since 1 French fry has 12 calories, F French fries has 12F calories. We're letting F be the number of French fries here. Therefore, the number of calories in F French fries and 1 hamburger is this. 1 hamburger has 600 calories, so that's 600 plus 12 times F. F French fries is 12 times F, so that's 600 plus 12F. And then the number of calories left for the day, we'll take that 2,000, we're going to subtract from it this whole expression, 600 plus 12F. Notice that the 600 plus 12F is inside the parentheses. Thus we're subtracting the whole expression from 2,000. And that minus sign is going to make that 600 negative 600, and the minus sign makes it 12F minus 12F. So you got 2,000 minus 600 minus 12F. Well, if you combine like terms, 2,000 minus 600, that's 1,400. And then you bring over the minus 12F. So the number of calories left for the day for Akiva would be 1,400 minus 12F calories. A teacher instructed a student as follows. Take any number and add 15 to it. Now multiply that sum by 4. Next, subtract 8 and divide the difference by 4. Now subtract 12 from the quotient and tell me the answer. I will tell you the original number. Now what you want to do here is analyze the instructions to see how the teacher was able to determine the original number. And on this next sheet, you'll see how this is done. So here you're going to translate this information in algebraic form. So here you're going to take any number, and in symbolic notation it's going to be n. Since any number is used, we need a variable to represent the number, so you're going to let n be that variable. Then next you're going to add 15 to it, which represents by n plus 15 in symbolic form, as we're told to add 15 to whatever n is. It refers to the variable n. Then you're going to multiply that sum by 4. So you'll take that n plus 15 it's all going to be multiplied by 4. So you have 4 times the quantity n plus 15. And then you're going to subtract 8. So you're going to take this expression, and it's going to be minus 8 from that. So you have 4 times the quantity n plus 15 minus 8. And then you're going to divide that difference, which is this right here, by 4. So all of this, 4 times the quantity n plus 15 minus 8, all that's divided by 4. And it's written like this. Then you're going to subtract 12 from the quotient and tell me the answer. So this will be subtracted from 12, so that's going to be minus 12. But you subtract 12 from all of this. So it'll be 4 times the quantity n plus 15 minus 8, all divided by 4, and then minus 12. Okay, so on the next side, you'll see that particular algebraic expression. So translating what the teacher told the class to do results in the algebraic expression 4 times the quantity n plus 15 minus 8, all divided by 4, then minus 12. So the teacher is told the answer obtained, and then she produces the original number. Now we're going to use the work backwards strategy to determine what happens. Let's say the final result was R, that the student gave the final answer. We'll just say it's R. The last step was to subtract 12, so we're going to add 12 to reverse that operation. So we're going to take R and add 12 to the R, so it'll be R plus 12. The step before that was to divide by 4. Or to reverse that, we're going to multiply R plus 12 by 4. So here you're going to have 4 times R, that's going to be 4R, and then 4 times the plus 12 will be plus 48. So that's going to be 4R plus 48. The step before that was to subtract 8. So to reverse that, we're going to add 8 to the 4R plus 48. Okay, scratch out this by 4. So you're adding the 8 to the 4R plus 48. So 8 plus that 48 will be the 56. So you have 4R plus 56 as your next algebraic expression. The step before that was to multiply by 4. So we divided the 4R plus 56 by 4. Here 4R divided by 4 will leave you with R. 56 divided by 4 will be 14. So you have R plus 14. And the step before that was to add 15. So the opposite would be subtracting 15 from the R plus 14. So in other words, you're going to have R plus 14 minus 15, which will leave you with R minus 1. Okay? So the original number is going to be 1 less than the result, or the result is 1 more than its original number. Okay? So if the result, let's say for example, was 27, then the original number will be R minus 1, or 27 minus 1, which will be 26. Okay? Now let's look at this example. The figure below shows a sequence of figures containing small square tiles. Some of the tiles are shaded. Notice that the first figure has 1 shaded tile. The second figure has 2 times 2, or 2 to the second, shaded tiles. The third figure has 3 times 3, or 3 to the second, shaded tiles. Now the next question is, how many shaded tiles are there in the nth figure? Okay, so here the squares of the shaded tiles have sides with increasing lengths, 1, 2, 3, and so on. So in the nth figure, the length of the side of the shaded region would be n. So hence the nth figure will have n to the second shaded tiles. Okay. Now how many white tiles are there in the nth figure? Okay, the number of white tiles on a side is 2 more than n, or n plus 2. The number of white tiles could be 4 times less any overlapping counting. In this case, each corner tile will be duplicated by 4. So if I pull up that slide here, this will be 2 times n, but keep in mind that these corner tiles will be duplicated on those 4 corners here, and the same with these 4 corners here, and the same with these 4 corners. They will be duplicated. Okay, so here in this case, each corner will be duplicated by, so 4 white tiles are overcounting, giving us 4 times, in parentheses, n minus 2, n plus 2, I'm sorry, minus 4, or 4n plus 4 white tiles. Another way to count the white tiles in the nth figure is to count the total number of tiles and then subtract the total from the total number of shaded tiles. Okay, so in other words, I'll pull this back up. Okay, you want to count the total number of tiles and then subtract that from the total number of shaded tiles. Let's say in this one, we have 9 tiles altogether. One of them is shaded. So 9 minus 1 will give you the 8. In this case, we got 16 tiles. 4 of them are shaded. 16 minus 4 would be 12. This one has 25 tiles. 9 of them are shaded. 25 minus 9 will be 16. Okay, in the arithmetic sequence with the second term 11 and the fifth term 23, we want to find the 100th term. Okay, now notice at the top I've written the formula for finding the nth term of any arithmetic sequence. That's a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Okay, now the second term is 11. So here, that's your a sub n, which is 11. And that's equal to a sub 1, which is what we're trying to find. N is going to be 2, so that's 2 minus 1, which is 1 times d. So that's where this equation came from. Okay, now probably it would help if I just work it out myself, because this slide just missing some steps here. Okay, the second term was 11, that's your a sub n. And that's equal to a sub 1. We don't know what that is. That's the first term. Plus your n is 2 because that's the second term. 2 minus 1 times d. So here you have 11 is equal to a1 plus, well, 2 minus 1 is 1, but 1 times the d is d. So that's where this came from. Okay. And then we're told that the fifth term is 23. Okay, using this formula again, you have a sub n, which is your fifth term, that's 23, is equal to a1 plus the fifth term is your n, that's 5, minus 1 times d. Well, 5 minus 1 is 4, so that'll be 23 is equal to a1 plus 4d. Which is the same as saying a1 plus 4d is equal to 23. Okay, now they took this, that a1 plus 4d, broke that up into this, a sub 1 plus d plus 3d. Because 4d is the same as d plus 3d. They just broke this up. So a1 plus d plus 3d is equal to 23. Well, what's a1 plus d? That's 11. So they just substituted this with 11. So you have 11 plus 3d is equal to 23. And then subtract 11 on both sides, you get 3d is equal to 12. And then d is going to be equal to 4. Okay. Now another way you could have did that particular problem is this. If I know that 11 is equal to a1 plus d, if I get d by itself, that means d is equal to 11 minus a1. That's just getting the d by itself. And then substitute 11 minus a1 in for d in this equation. 23 is equal to a1 plus 4d. I'll show you how this is going to be done. You got 23 is equal to A1 plus, I take that back. You want to find out what D is. And that wouldn't help any. If I get the A1 by itself, then you'll have A1 is equal to 11 minus D. Okay, and then we can do some substitution here. 23 is equal to, this A1 can be substituted with 11 minus D plus 4D. Now here, negative 1D plus 4D is 3D, so you'll get 23 is equal to 11 plus 3D, and then subtract 11, you'll get 12 is equal to 3D, which means if you divide by 3, D is equal to 4. Okay. So here the common difference here is 4, which is exactly what they have here. Okay, now in the arithmetic sequence, well, that's the directions here. Now we want to find the first term. We have 11 is equal to A1 plus D. We found out that D was equal to 4, so replace the D with 4, so you have 11 is equal to A1 plus 4. Subtract 4, you're going to get 7 equal to A1. So the first term of that sequence is 7. Now to find the 100th term, and again I'll write the formula, A sub n is equal to A1 plus the quantity n minus 1 times D. In this case here, A1 was 7. So we're finding the 100th term. So A1 was 7. And n is 100, so that's 100 minus 1 times D. 100 minus 1, that's 99, so, and actually D was 4. So this is 99 times 4 plus 7, which will get you 403, which is what they have here. So the 100th term of that arithmetic sequence will be 403. Okay, here we're looking at a geometric sequence, 2, 3, 9 halves, 27 fourths. Here we want to find the nth term of the geometric sequence. In this case here, the ratio of the common sequence can be found by dividing two consecutive terms. If I do 3 divided by 2, those are two consecutive terms, and those are the easy ones to do. So if I do 3 divided by 2, that's going to be 3 halves. So 3 halves is your common ratio. And this is the formula for finding the nth term of any geometric sequence. A sub n is equal to A sub 1 times r to the n minus 1. A sub 1 is the first term. The r is your common ratio. N is the term that you're trying to find. So in this case, A1 would be 2. That's the first term. R is going to be 3 halves, and that's to the n minus 1. So that's the formula for finding the nth term. A sub n is equal to 2 times 3 halves raised to the power of n minus 1. Now, the geometric sequence has the first term of 3 and a ratio of the square root of 2. Find the 10th term. Okay, we know the first term. That's your A1, which is 3. We know what the common ratio is. Square root of 2. That's given to us. We're going to use this formula. A sub n is equal to A sub 1 times r raised to the n minus 1. Okay. So here this will be A sub n is equal to A sub 1, which is 3, times r, which is the square root of 2, and it's raised to the n minus 1. Okay. That's the general formula for finding the nth term of a geometric sequence where the first term is 3 and the common ratio is the square root of 2. Now we want to find the 10th term. So n in this case is 10. So in this case here, A sub 10 is equal to 3 times the square root of 2, raised to the n minus 1. Okay, let me correct this so y'all can see that that is supposed to be the square root of 2. Okay. And that n is 10, so that should be 10 minus 1, by the way. Now, if I simplify this a bit, you have 3 times the square root of 2. I'm going to keep that in the parentheses. Then 10 minus 1, that's going to be 9. Okay, now square root of 2, if I write that as in exponential form, that would be 2 to the 1/2 raised to the 9th. Because square root of 2 in exponential form will be that number to the 1/2. Because it's square root. And then I'm raising a power to a power so I can multiply your exponents here. So this would be 3 times 2 to the 9/2. Okay, which is what they have here. And then from here, I can break up 2 to the 9/2 as 2 to the 8/2 times 2 to the 1/2. Because I know 8/2 and 2/2 added together will give me 9/2. Now, 2 to the 8 over 2, I can divide 8 by 2 to get 4, so it'll be 2 to the 4th. So I have 3 times 2 to the 4th times 2 to the 1/2. Well, 2 to the 4th is 16. 16 times 3 will give me 48. And then that 2 to the 1/2, I can rewrite that as the square root of 2. So the final answer there will be 48 square root of 2. Okay, look at this example here. At a local farmer's market, 3 purchases were made for the prices shown in the figure. How much does each object cost? Now you're told here that this first one has a cantaloupe and a vase with a flower in it. It costs $8. A watermelon and a vase with a flower in it costs $9. A watermelon and a cantaloupe are $7. Okay. Now here's how we're going to solve this particular problem. Let's suppose that the objects in the first 2 purchases are put together. Okay, so here, put these 2 together, you'll add 8 and 9, you'll get $17. So the cantaloupe, watermelon, and 2 vases with a flower in it will be $17. Okay, now let's look at this. If the cantaloupe and the watermelon are taken away from that total, then according to the cost of those 2 objects from the tag on the right, the cost should be reduced to $10 for the 2 bases. Because if you look at this, a cantaloupe and a watermelon cost $7. Take these away, that means you're going to subtract $7 from the $17. That would give you $10. So that means that the cost of these 2 vases has to be $10, which means each of the 2 vases will have a cost of $5. If that's the case, then let's go back to our figure here. Let's go back to the original one here. If this vase costs $5, the total is $8, so that means that the cantaloupe must be $3. You subtract $5 from the $8 to get the cost of the cantaloupe, which is $3. Same thing here. This is $5. That total is $9. Subtract 5 from 9, you're going to get 4. So the cost of the watermelon is $4. Okay. And sometimes you have to use intuitive thinking to come up with the correct answer that you want. And this will conclude that video on variables.